countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And good evening to all teachers, parents, and wonderful students. Okay, so welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. So how's everyone doing today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noor. You can call me Madam Nun. I am lecturer from College Matrikulasi Negeri Sembilan. I am your moderator for today's class. The most important person today is our passionate and fantastic presenter, Madam Rusmaya. She is very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to our presenter. So for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. As usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of the session. Remember that you can only use the email to claim the certificate. For credit claim, you need to collect the 1 letter and 4-digit code which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind students, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I'm pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box, and we will try to provide you with the answers. Before I give Madam Rosmaya to present, I will announce the first digit code for the credit claim. So the digit code is A17. 17. Okay? So without further ado, please welcome Madam Rosmaya to start her presentation.
Okay, thank you to Madam Non, okay, to our moderator for today. Okay, so now I'm going to open my slide. Okay, it's open already. So let me introduce the PU teams that we have in Academy YouTuber. Okay, so this is Maths team led by teacher Im. Okay, and this is Biology team. Okay, led by Cikgu Faiza. And chemistry team, okay, led by Cikgu Shahnun, and perakaunan and economy Prayu, led by Madam Fizi. Okay, and our physics team, okay, led by me, and together with us, Madam Non also is in the physics pre-U team in Academy YouTuber. Okay, so now we have come to the main objective for today's live class. Okay, so what is our learning objective for today? So we are going to solve questions on mechanics and thermodynamics. Okay, so the PDF question link have been given already in the description below. And also at the chat box. To those who has done the questions, congratulations to you, and you can write your answer in the chat box. Okay, so now let's go to the first question. Okay, so let's read the question. Okay, the length of a strip of paper is 22.3 centimeter and its width is 1.235 centimeter. So the perimeter of the strip to the correct significant figure is, okay, so the perimeter formula, okay, you know already, right? So you add up all the length and the width, okay, for this strip of paper. So you get the answer 47.070 centimeter. But you cannot write your answer like this because the number of significant figure here not the same. So how to write the answer if this involve addition? So you follow the least number of decimal place if involve addition. So and also subtraction. So we have one decimal place here. This is the least number of decimal place. So your answer, you round off to 47.1 centimeter. So that's the correct way to write down your answer. Okay. Okay, next we go to question 2. Okay, a car and a lorry pass a point P in the same direction along a road at time t equals to 0. So the speed time graphs of the vehicles are shown in the figure. Okay, graph is given here. So the lorry overtakes the car after. Okay, so when the lorry overtakes the car. So those who have done the question, you can write there in the chat box. Okay, you can imagine this lorry, pass from a point, okay, together with the car, and then the lorry overtakes the car when they are at the same distance. Okay, when they are at the same distance. So we use distance formula here, but the distance from the speed against time graph, we can calculate using area under the graph. Okay, so you must know what we can get from the different graphs, speed time graph or displacement time graph or acceleration time graph. Okay, so we can do two analyses from the gradient and also from the area under the graph. So in this case, to find distance, we use area under the graph, okay, from the speed time graph. Okay, so at the same distance, you do try and error. So which area under the graph that provide same distance. So it is found at time 16. So let's try. Half times, this is area of a trapezium. So 4 plus 20 here, and then times the height of the trapezium 16. So you get 192 meter. And for the car, look at the car here. So when we calculate the area under the graph until 16 second here, we also get the same area. Okay, so the area of the trapezium under the graph car here is half times. Okay, the same the parallel length is 20 and 4 times the height also 16. So you see we get same gradient, same area under the graph. So this means at the same distance. So this is the time where the lorry overtakes the car. So the answer is C. Okay. Okay, now we go to the question 3. Okay, question 3. Okay, looks like nobody answer right in the chat box. Okay, never mind. You can refer to the this video later when you can repeat watching this video after the class end. So do not worry. So we go to question 3. Okay. A bullet is fired horizontally from a gun. At the same time, from the same height, a bullet is dropped. So if we neglect the effects of air resistance, how will the time the two bullets spend in the air compare? Okay, so how to imagine this? Okay, I have a animation here. Okay, can you see or not? at the same time in this experiment done, similar to the when we fire a gun lah, but this is the ball, the iron ball. Okay, so it is shoot there, you see, and then at the same time it is also dropped from the same height. So you see they reach at the same time on the ground. So the answer is D. Okay, both bullets will spend the same amount of time in the air, hitting the ground at the same time. Okay, I hope that the animation given here will give the idea. You manage to visualize the idea why both bullets spend the same amount of time in the air, hitting the ground at the same time. Okay, so we go to question 4. I hope I'm not explaining too fast. Okay. But it's okay. You can write there in the chat box if you don't understand. Question 4. We go to question 4. A 20 kilogram mass is acted upon by a force F, and the mass moves from rest in a straight line. So the force changes with the body's displacement as shown by the graph. So find the body speed when displacement is 18 meter. So where is 18 meter? There, 18 meter. And what kind of graph is this? This is force against displacement. Okay, force against displacement. So remember that from graph given, there are two analyses can be done. Area under the graph, the first one, and the second one is the gradient. So in this case, this is force against displacement. So that means there's something to do with the area under the graph. Okay. So let's check what is given in the question. So we are given mass. Because labeling like this might help you to get the idea which formula to be used. Okay, so here move from the rest. So this is hidden information we can get here. So this means that initial velocity is 0. Okay, then we are going to find the body speed. Okay, this is final velocity. Okay, when displacement is 18. So this is initial. Initial velocity is U 0 and V is what we are going to find. Okay. And also displacement. So from the M, S, U here, M. So we can use, okay, and then the speed, okay, and from the force against displacement graph, so area under the graph is the work done. Okay, this is what you need to know. You need to another confused that make you confused is force against time graph. For force against time graph, area under the graph is impulse. But for the force against displacement, so area under the graph represent work done. So you must be very careful between these two type of graph. So for force against displacement graph, area under the graph is the work done. Okay, from the formula, from the in mathematical form, we write like this, integration. So this means area under the graph. Okay, so we use work energy theorem later to find the speed. For the work done. So what is work energy theorem? So the work done means the change in kinetic theory. So from the kinetic theory, we can find speed. Okay, so that's how to analyze the graph. Okay, now we calculate the area under the graph. There are two parts here, the positive part and the negative part. So the negative part means we minus the area. Okay, so for this first part is shape of the trapezium. So you use area of a trapezium, half times the two parallel length is 6 plus 12, and then the vertical length between the two parallel length is 8. And then the below here is the shape of a triangle. So you use area of a triangle. So half times 6 times 4. Okay, the shape of the triangle. So you get the answer 60 joule. So this is the work done. And then what is work done? Work done is change in kinetic energy. So now we can use change in kinetic energy. Final kinetic energy equals to initial kinetic energy. So that means half mv squared minus half mu squared equals to 60 joule. Okay, so we substitute the values given here. Mass 20 and then the u 0. So we now remain is only one unknown, right? So you can calculate using, you get V equals to 2.4 meter per second. So the answer is A. Okay, simple, right? Okay, next we go to question 5. Okay, question 5. In an experiment, a neutron is forced to collide head-on with a nitrogen nucleus. So the relative atomic mass of neutron is 1 and that of nitrogen is 14. So the collision is elastic. And the final velocity of neutron is, okay, so this is elastic. Elastic, so what is meant by elastic? So elastic means the collision, the conservation, there is a, we can use the principle of conservation of kinetic energy. So kinetic energy is constant. Total of kinetic energy is constant. So that is what is meant by elastic. So you must know that. Okay, so the final velocity will be, okay, imagine this is neutron, this is nitrogen. So you see the relative atomic mass of neutron is 1, then that of nitrogen 14. So this means we can imagine that neutron is very small in mass compared to the nitrogen. So when collision happen, so neutron will move with less velocity compared to the, and the nitrogen will higher, will get become higher velocity because kinetic energy is conserved or constant. Okay, so that's mean the velocity of the neutron will become lower magnitude than the initial velocity. Okay, so we go to question 6. Okay. Okay, we read the question first. So now the questions become harder and harder. Okay, so a spring of original length L and force constant K is placed on a smooth horizontal surface. Okay, can you imagine this or not? Okay, the spring now move in a smooth horizontal surface. Then one of the springs end is fixed at a point 0 and another end is fixed to an object of mass m. So if the object moves in a horizontal circle about point O with a constant angular speed omega, so what is the radius of the circle? So we are going to find radius of the circle here. So there's something to do with the centripetal force. Okay, centripetal force. Okay, so I draw first the diagram. Diagram not given, but you can imagine like this. And then analyze also what is given in the question. So you are given L length and then force constant and then the mass of the object and then the angular speed. So we are going to find radius. So in your mind, you must imagine, okay, there's a spring. The spring length is L. This is original, original spring length. Okay, then it is put on the smooth horizontal surface. Okay, so the object attached to it. Okay, this is a fixed point O, okay, as mentioned in the question here, okay, point O. Then the spring is rotating, okay, so it's rotating with angular velocity omega. So this diagram might help you to imagine. Okay, so now we are going to involve centripetal force. Okay, another one is because this is spring. Okay, so what provide the centripetal force here? Okay, so there must be, okay, you see the question here got given a force constant, right? So that's mean tension in the spring provide the centripetal force. Okay, so you form two equations. One is the spring tension in the spring, which is given by F equals to Kx. Okay, tension in spring Fs. Okay, given by Kx. Okay, so you substitute the extension. Okay, the original length is L. So the object move in a circular motion with radius R. So that means the extension will be R minus L. Okay, can you see now? So by drawing sometimes might help you to imagine this. Okay, so this is the radius of the circular motion and L is the original spring. So the extension will be R minus L. So you substitute into here. So you get tension in the spring. Okay, this is equation 1. Another equation comes from the circular motion, centripetal force. So because angular speed is given, there are three formula for centripetal force. Which is equals FC, centripetal force, equals to mv squared per r, equals to mv omega, and equals to mr omega squared. So we choose this one because omega is given and we are going to find radius. So we choose centripetal force equals to mr omega squared. Okay, so now the centripetal force is provided by this tension. Okay, so you substitute this tension into the second equation and then solve to get the radius. Okay, so now okay, another one. remember that the question also mentioned smooth horizontal. So smooth horizontals means no frictional force involved. If it's a rough surface, so the centripetal force also is provided by the frictional force. But in this case, we can ignore the frictional force because mentioned here smooth horizontal surface. So now the centripetal force is only comes from the tension in the spring. Okay, so you substitute the uh, kx here into here, okay? 1 into equation 2, and then you solve for r, right? Bring k to the right side, and then we want r, right? So combine the r here, factor out r. So bracket 1 minus m omega squared per k, okay, equals to L. And then we make this as single fraction, and then we bring to the right side, and you solve until you get what given in the answer lah. It's similar to B. So the answer is B. Okay. Okay.
Okay,
So
Madam Rosmaya. Before
okay.
we proceed, can I announce the second digit code?
Okay.
Okay, so class, the second digit code is number 4. Okay,
Okay. Number
second digit
4.
code is number 4. Please jot it down somewhere, okay? All right, Madam Rosmaya,
Okay.
you can continue. Thank you.
Okay. Okay, I can see there. Alpha Danish, you Alpha faham Okay, very good Alpha. Okay. So now we go to next question. Question 7. Question 7. Okay, the minimum speed required by a body to escape from the gravitational pull of a planet does not depend on. Okay, so now does not depend on what? Okay, the key word here, minimum speed, and then the body escape from the gravitational pull of the planet. So you can imagine whatever the body is. Let's say you imagine it as the body is a satellite. So a rocket bring a satellite to certain height on the planet. Okay, so that's mean we need to use here principle of conservation of energy. For the minimum speed for the body to escape from gravitational pull of the planet, we use physics concept here is principle of conservation of energy. Okay. Uh, so total energy means that total energy is always constant. What is the principal conservation of energy state? So it state that total energy is always constant. So imagine the earth and then the body is the rocket. So initial total of kinetic energy plus potential energy at the initial, okay, equals to the total of kinetic energy and potential energy at the height where it free from the gravitational pull of the planet. Okay, at initial, let's say the kinetic energy is half mv squared. Okay, then the potential energy is negative gmm per hour. Okay, remember that the radius here measured from the center of the earth, r, so negative gmm per hour. Okay, at the point at the height where the rocket is free, or the body is free from the gravitational pull of the earth, is where the kinetic energy is zero. Okay, because we want minimum speed. So we want minimum speed. So at that time, the kinetic energy is zero and the potential energy is zero. This is where the rocket start to feel free from the gravitational pull of the earth. Okay, so we substitute these two into the equation here. Okay, then we arrange the equation. So you get this equation. Okay, so now we can cancel the m, and you see what is small letter m here? This is m of the mass of the object. So that's mean it doesn't depend on the mass of the body. Okay, for the speed, this is the minimum speed of the body. Okay, in this case is the rocket to free from the gravitational pull of the earth. So it doesn't depend on the mass of the body. Okay, very clear from the equation here. Okay, so alpha C, correct? C. Okay, so we go to question 8. Okay, question 8. We read the question. Which of the following shows the correct relationship between potential energy U, okay, kinetic energy K, and the total energy E of the satellite. Okay, for this, to show the relationship, okay, between the U, K, and E, so you must know the equation, formula for U, K, and E. Memorize this equation, okay, for K, for U, and for E. Okay, formula for K, Gm per 2R. Okay, formula for U is negative Gm per R. And formula for E, total energy is negative Gm per 2R. Okay, so you usually student make mistake here between K and E. You see the difference or not? One got negative, total energy got negative here, but kinetic energy doesn't have negative. Okay, I don't want to discuss how to derive these equations. You all supposed know already, so you can refer how to derive this equation later. Okay, so I can see from the chat box there, Arfat think B. This question, or I think B. This question, I don't know. Given there already the B, but Alpha guess same also B. Okay, so now how to get B answer. Okay, so K is Gm per 2R. Okay. So U equals to negative 2K. So you can use substitution method, or you can use the equation ratio method to get the relationship between U and negative 2K. So let's say I use substitution method. So the 1 per 2 can be factored out. So bracket is Gm per R. And you see Gm per R, this is U, right? But no negative here. So you put together the negative, okay? Negative U. And you cross multiply and you get U equals to negative 2K. So by doing this only, we can know that the answer is B, because A, C, D totally out, because the K here no 2, together with the K as a coefficient. Okay, but we just try for the 2E here. Okay, we try. Okay, so we can use the same method, or you can also use a ratio method. Actually, ratio method is the faster one, but it's okay. We just try. Okay, so we factor out half. So bracket here is negative Gm per R. Okay, Gm per R is U, so you substitute there U. Here already got negative, right? So you just substitute U and you can see that U equals to 2E. So the answer is B. Okay. Okay. So that's the answer. Okay, now we go to question 9. Okay. So we read it together, the question. Okay, forces of 7 Newton and 10 Newton act on a square metal plate of side 0.50 meter as shown in the figure. So the metal plate is freely pivoted about a horizontal axis through its center of gravity G. Okay, so what is the resultant torque on the metal plate? So the question asks here the resultant torque. So that's mean the plate is not in equilibrium. Okay, so the plate is not equilibrium because of the angle of force applied here in this way. You see, perpendicular to each other. So that's mean the plate also must be rotating also. The final result. Okay, so what is the resultant torque? So you need to find the torque for because of this force 7 Newton and also because of 10 Newton. So what is the formula for torque? Okay, so this is rotation because of the 7 Newton. Look at the force direction here. So it will rotate in the clockwise. Okay, whereas the 10 Newton will make the metal plates rotate in and counterclockwise. Okay, okay. So we calculate the torque by each of the force here. So torque formula is force cross D. Okay, force cross D, where force and distance must perpendicular to each other. Okay, not like work. It's similar to work. Work is force time distance parallel to each other, but this one torque is force time distance perpendicular to each other. Okay, for 7 Newton, the perpendicular distance is 0.25 because 0.5 here, half of the 0.5 is 0.25. Okay, so this is the perpendicular distance from G. From G, we choose a fixed point. Fixed point G. Okay, because the metal plate is freely pivoted about the horizontal axis through its center of gravity G. So the measurement of the distance must from G. So it's 0.25, okay, from the force here, vertically, okay, or perpendicular to the force. Now we go to second one. Okay, we calculate, we get 1.75 Newton meter. And then for 10 Newton also we do the same. Okay, the perpendicular distance also 0.25. Okay, because half of the 0.5 here, this is square metal plate. So half of it is 0.25. So the answer is 2.5 Newton meter. And you can see that, okay, they are different in magnitude. So they have resultant, they have resultant torque. Okay, so you minus these two. So you get the resultant 0.75 Newton meter. So which one is larger? 2.5 is larger, right? And 2.5 comes from the 10 Newton. So that means it's rotating in a counterclockwise direction. Okay, because 2.5 is larger. So larger minus smaller give you positive, also counterclockwise. Okay, very good, Afa. You understand?
Okay, Madam Rosmaya, would you like to take a break for a while for the advertisement?
Okay, 30 minutes already, yeah? Okay, yeah, let's take a break.
Yes.
Stay tuned. Okay.
Okay.
Berita baik untuk semua. Kini, Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, student. I give back to the Madam Rosmaya to continue with her presentation. Okay, Madam Rosmaya, you can continue. Thank you.
Okay, thank you, Madam Nun. Okay, so now let's go to question 10. So we read the question first. Okay, which of the following shaded areas best represent the amount of strain energy per unit volume stored in a wire when it is loaded? Okay, so we have four kinds of graph here. Force against stress, force against extension, force against strain, and stress against strain. Okay, so what's your answer now? Can write there in the chat box. Okay, so the answer is D. Do you get D or not? Okay, so why the answer is D? Okay, so you can use a stress formula here. Remember that from the graph, okay, from the graph, there are two analysis can be done. First the gradient and second is area under the graph. So in this case it's area under the graph. Okay, so now stress formula is force per area, and then strain is an extension per length, original length of the spring or whatever lah. Okay, and extension per length, original length. Okay, so now this is area under the graph, and the shape of the area under the graph is a rectangle. So you use a rectangle formula. So half time base times height. Okay, the base is the stress. Okay, the base is the strain and the height is the stress. Okay, so now you substitute this formula into the equation. Okay, so now you rearrange this, okay, so that we can get similar to what asked by the question, energy per unit volume. Okay, so half FE combined together, and then A area times length. So area times length. Area, this is a cross-sectional area. So cross-sectional area times the length is the volume. Imagine the wire. Imagine the wire as a cylindrical shape. So the cross-sectional area is the A, and then the length of the wire is L. So you can imagine the wire as a cylindrical shape. So it gives you the volume of the wire. Okay, so and half Fx is the energy. is the energy strain. Sorry, it's the energy. So half Fe is energy per unit volume. So that's why the answer is D. Okay, so we go to the next question. Hopefully you can understand this. We go to question 11. Okay, figure below shows the graph P against 1 per V. Okay, for a fixed mass of an ideal gas experiencing isothermal change. Okay, you are given this graph. If E is the average kinetic energy per gas molecule, so the possible value for the number of molecules in the gas sample that can be deduced from the graph is, okay, so this is in thermodynamics topic. Okay, so the graph P against 1 per V. Look at the graph. It's P against 1 per V. And another one, this is isothermal change. So for isothermal change, remember that temperature is constant. The changes is between P and volume. Okay, P and volume. And for P against 1 per V, you get a straight line graph. Okay, so you must know the formula for the PV. PV, there are two formula. One is NKT. Another one is nRT. So the NKT here, the N is a number of molecules, K of the gas, K is the Boltzmann constant, T is the temperature. Temperature is constant. Okay, another one is PV equals to nRT, but the N is a number of moles. So we choose this one. We choose this one because the question asks what? The question asks, so what's the question asks? The question asks the possible value for the number of molecules. So the alpha, the K is small letter. Boltzmann constant small letter. Okay, so the possible value for the number of moles in the gas is this N. So this is what we are going to find. Okay, so we cross multiply one V here becomes 1 per V and KT. Okay, so compare with the graph here. Okay, so you've learned in form 4, form 5 where the linear graph is in the form of y equals to mx plus c. In this case, it passed through the origin. So that means the c is 0. So you use y equals to mx only plus 0. So no need to put the 0 lah. Y equals to mx. So now compare with the graph. The py axis is p and the x axis is 1 per v. Okay, so what does NKT means? NKT means the gradient. Okay, the gradient. So the gradient of the graph, refer to the graph here is vertical distance divided by horizontal distance. Okay, so formula for the gradient. So it's B per A. Okay, now we compare this gradient B per A with this NKT. So compare with the equation, from the equation and with the graph. So gradient, like I said just now, we have two analysis from the graph. One is area under the graph, another one is gradient under the graph. So in this case, it's the gradient under the graph. So the gradient under the graph B per A, okay, is given by NKT. Okay, now you can solve for N. Okay, solve for N. But the question also, yes, Alpha. I know you are from you are year 5, Alpha. But it's very good. You maybe in the future it's here for you. Okay, so now the energy of the average kinetic energy per gas molecule is E equals to 3 per 2 kT. So how to derive the formula also I don't discuss in detail. So just we get straight to the formula. Okay, so a formula for the average kinetic energy per gas molecules is 3 per 2 kT. There are two formula, 3 per 2 kT. Another one is the use the KR, R per Avogadro number. 3 per 2 RT per Avogadro number. But we choose NKT lah because we are going to relate with this PV equals to NKT. Okay, there are more than one formula here. So we choose E equals to 3 per 2 kT. Okay, so now this is second equation. This is first equation. So the second equation, we choose this one. We don't choose this one. Okay, now we substitute into here the KT. Cross multiply, we get 2 per 3E. Okay, cross multiply, we got 2 per 3E. Okay, then we rearrange the equation to get number of molecules. So what's the answer? The answer is C. 3B per 2AE. Okay. Okay.
Okay, Madam Rosmaya, I will announce the third digit code for the credit claim. Okay,
Okay.
hi everyone. Please listen carefully. The third digit code is number 3. Okay,
Okay,
number
number 3.
3. All right. So, Madam Rosmaya, you can proceed with the presentation.
Okay, now let's go to the question 12. Question 12. The RMS speed of an ideal gas at 27 degrees Celsius is 0.3 meter per second, and its RMS speed at 927 degrees Celsius is. Okay, so the formula we need for this equation, okay, is the RMS speed. So there are three formula. We have derived this and also we discussed this actually last week. Okay, last week. Okay, so I don't want to go through detail. So which one to choose? We just take the relationship between RMS speed and the temperature because here given temperature and the RMS speed. K is constant and M also is constant because the same gas and then change temperature only. So the M is also constant. So the changes is between RMS speed and the absolute temperature T. So that's mean V is directly proportional to the square root of T, absolute temperature. So we just take this one and you form equation. Use a variation method you've learned in Form 5, okay, maths, if you can remember. So that's mean the equation form here is V1 per V2 and then square root of T1 per square root of T2, okay. Or another method you can use, you form two equations, then you use ratio, or you can use substitution method. So many methods can be used. So choose this one is the best, it's faster. Okay, so now substitute the speed 0.3 meter per second. So V2 and then temperature, don't forget to convert to absolute temperature Kelvin, formula Kelvin. So degree Celsius convert to Kelvin is plus 273. Sorry. Okay, so 927 plus 273 is to convert the temperature degree Celsius to Kelvin. Okay, so be careful because the temperature is in Kelvin unit. So if you don't do this, then you won't get the answer. Okay, so now you cross multiply, you get 0.6 meter per second. Okay, the answer is B. Okay. Okay, now we go to next question. Question 13. Also on thermodynamics. Okay. Okay, the temperature of a fixed mass of monoatomic gas in the state L, here shown in the diagram below, is T1. Okay, this is the isotherm with temperature T1 because T constant, T1. So this is the isothermal change. And then the temperature of gas can be increased to T2 by the process Ln and Lm. So this is another isotherm. The temperature is T2. Okay, the heat required for the process Ln and Lm are Q1 and Q2 respectively. So we are going to find the ratio of Q2 to Q1. Okay, the ratio Q2 to Q1. So what is the relationship between Q here, okay, and the pressure, volume, and then temperature? So we go to the PV, isothermal change. Isothermal change. Okay, so and then another one, look at the answer here. Can you see or not? 3, 5, 7. What does this means? Sometimes by referring to the answer given, it helps you to imagine which formula to be choose. Because in this topic, thermodynamic topics, there's a lot of formula, right, to memorize. So by combine all this, you can see that this must be related to degree of freedom. Okay, the formula we are going to choose is related to the degree of freedom. Okay, so now let's look here. Monoatomic gas. So the degree of freedom is 3. Memorize that for diatomic, the degree of freedom is 5. For polyatomic, the degree of freedom is 6. So for monoatomic, the degree of freedom F is 3. So memorize this. Okay, and then you are given T1, you are given T2, you are given Q1, and you are given Q2. Okay. Okay, so that's mean the relationship between all these is Q equals to N CVM delta T. C is the molar heat constant. Molar heat constant. Molar heat capacities. Molar heat capacities is a constant. Okay, molar heat capacities at constant volume. Okay. And then the Ln is the use formula MCPM delta T. Okay, because the process here involve constant pressure. So you use formula here, in this formula, use molar heat capacities at constant pressure. Okay, use the formula of this one. Okay, N is the number of moles, and then delta T is the change in temperature. So from T1, T2 minus T1, final minus initial. So they are the same, actually, the same process. Okay, the same change in temperature. Okay, QLN, QLM. But the Q1 and Q2 is different. Okay, CV, CVM, CPM is different. What else is the same? N is the same because it comes from the same gas. Okay, it comes from the same gas here. Okay, and then in different process, two different process. So that's mean the N is constant, comes from the same gas. So N and delta T is the same. So therefore, the changes is between Q and C only. Okay, so you can, using ratio method, you can cancel N and temperature. So we don't use these two. We just use Q1 per Q2. Okay, substitute the Q1 and Q2 into here. So Q1 per Q2 equals to CVM per CPM. So we can get ratio here, Q2 to Q1. Okay, so now what is the CVM formula related to F? Okay, also last week we have derived the formula for CPM in the form of degree freedom. So it's half FR for CVM, and then CPM is half F if bracket F plus 2R. Okay, half FR divided by half F plus 2R. Also, I'm not going to discuss here. We proved already this in the last week. Last 2 weeks. Or you can refer to my video lah. Okay, how to derive this to to get this formula. Okay, now we go straight to the formula. Now we substitute 3 into F here. Okay, half 3R, and then below here half 3 plus 2R. Okay, cancel the R. R is the molar gas constant. Cancel half. So there you get the answer, 5 per 3. Okay, so the answer is C. Okay, the answer is C. Okay. So now we go to question 14. Question 14. Okay, a gas undergoes adiabatic expansion. So which of the following graphs shows the relationship between the absolute temperature T of the gas with its volume V? Okay, so here is graph ln T against ln V. So all the same. Okay, so what can we do? What is the analysis of the graph? Remember, there are two, right? Area under the graph and also gradient under the graph. Okay, so now what can we do? We use the equation formula relating these two, T and V. Okay, T and V. So the formula T and V and is adiabatic expansion. So for adiabatic expansion, so what is the formula related T to V? Remember, there are 3 formula. Okay, if you got the answer D, very good. Okay, so there are 3 formula for the adiabatic expansion. Okay, it's last week we discussed this. So P1 V1 to the power of gamma equals to P2 V2 to the power of gamma, and then T1 V1 to the power of gamma minus 1 equals to T2 V2 to the power of gamma minus 1, and P1 to the power of 1 minus gamma, T1 to the power of gamma equals to P2 to the power of 1 minus gamma, T2 to the power of gamma. Okay, so we choose the one that relate T and V only. So in this case, equation 2. Equation 2. Okay, from this equation 2, so we know that T1 V1 to the power of gamma minus 1 is constant. Okay, because they are equals here. So that's mean TV to the power of gamma minus 1 equals to constant. Okay, so we just put K for easier calculation. So we just put K. Okay, now we change this in the form of Y equals to MX plus C. Okay, remember form 4, form 5 we've learned in maths for linear graph, the equation is in the form of y equals to mx plus c. So let's look, which one? This is quadratic form. This is y equals to mx plus c form. Okay, and because all involve ln, so we use log rule. Okay, so put log both sides. So we got ln bracket TV to the power of gamma minus 1 equals to ln k. Okay. Then use again log rule, separate this. This is multiply, right? Multiplication. So means log t plus ln v to the power of gamma minus 1. Okay, separate this. We use log rule. Okay. Then because the y exists here, ln t is the y. So let ln t to one side. Okay. The rest we put on the right side. So plus ln v to the power of gamma minus 1 bring to the right side become minus. You can see already, right? It's a negative gradient. So this will be gradient. Okay. So ln v here is just ln v alone. No power here. Gamma minus 1. So we bring the power gamma minus 1 to the right side. Okay. So now we have this equation in the form of y equals to mx plus c. So y is ln t. X exists here ln v. Okay, x ln v. So gradient will be negative. You see here gradient is negative. Okay, so the c is this value. It has c. It has y-intercept. C is the y-intercept. So it has y-intercept. So answer C, the y-intercept is 0. So C out, A out. Answer A and C out already. Answer B also out because of the gradient. Gradient is not positive. The gradient is not negative. It's positive. So therefore the answer is D. Okay. Okay, so now done for question 14. So we go to question 15. Okay, so we have two metal rods here, M and M, of the same cross-sectional area, but of length 2x and x, joined in series and perfectly lag. So the ends of the combined rod are maintained at temperature theta 1 and theta 2. So here theta 1, theta 2. So theta 1 is larger than theta 2. So this means that the flow of heat is from theta 1 to theta 2. So the heat flow from high temperature to low temperature. Okay, this is very important. We know where the heat flow is. High temperature to low temperature. So the thermal conductivity is given. M has twice that of N. Okay, so now we use rate of heat flow formula. Okay, so same cross-sectional area, 2x, the length given, and then theta temperature given. So that's mean the formula is dq by dt equals to negative Ka d theta by dx. So dq by dt is the heat flow. So we use this concept, we form two equation. Because the rod is perfectly lag, so that's mean their rate of heat flow will be the same. Okay, their rate of heat flow will be the same because of the perfectly lag here. Okay, so we calculate one for each of the metal, the metal. Okay, M and N. So for M, okay, let's choose theta between the theta at the junction as theta, and temperature at the junction is theta. Okay, so we substitute the value negative 2K because twice thermal conductivity twice, so negative 2K. A cross sectional area is the same, so we just put A, and then the change in temperature, the theta here is change in temperature, final minus initial. So final will be theta because the heat flow this way. So theta minus theta 1 divided by 2x. Okay, so right side also the same. D theta is change in temperature. So which one is final? Theta 2 is final. The heat flow is this way to the right. So that's mean theta 2 minus theta. So theta 2 minus theta. Okay, thermal conductivity K, cross-section area is the same. So length is X. So you substitute everything. So you just need to be careful with the sign you use. So if you use a formula here negative, so this is change in temperature. Make sure the change in temperature is final minus initial. So lower temperature minus higher temperature, where the direction of heat flow is. So be careful, final minus initial. So this is where you need to be very careful. Okay, so now cancel everything that has same value. Cancel the negative, cancel the 2, cancel the A. Okay, so X, finally you get theta minus theta 1 equals to theta 2 minus theta. Okay, so now you rearrange the equation. We want this theta, right? So bring this to the right side. 2 theta equals to theta 2 plus theta 1. And the answer is half bracket theta 1 plus theta 2. So the answer is A. Okay, so very easy, right? Now you just need to memorize the equation. So this is objective questions. Okay, so now we go to the section B part. Question 16. Okay, so a body is suspended with an inextensible light string. Okay, light string means we don't involve mass of the string here. The body is then rotated vertically with a radius of rotation L, okay, about O, okay, O. Initially, the body is launched from the lowest point, okay, with the velocity u in the horizontal direction of the highest point Q. Okay, here is highest point Q. Okay, to complete the circle. So state the necessary condition for the body to reach Q. So for the body to reach Q, okay, the string must be under tension. Okay, in other words, the tension of the string here must not be zero. If the tension is zero, what happen? The what is this? The body will drop. Not manage to be at the highest position. So the tension must be there because the tension provide the centripetal force. Okay, the tension provide the centripetal force in this case. So there must be tension. Okay, there must be tension. Okay, so that's the answer for this question. The condition for the body to reach Q. Okay, next question is determine the minimum velocity at Q in terms of U for the body to continue in circular motion. Okay, for the minimum velocity, okay, minimum velocity, the tension is zero, must zero and above. So to get the minimum velocity, we use this tension as zero for the guideline. Okay, it cannot be zero, but for the guideline, for the minimum velocity. So the tension must be larger than zero. So we use, you substitute T0 into the equation. The equation from the centripetal force. Okay. And another one is we also need to use what you call that, principle of conservation of energy. So there are two formula we are going to use here. Okay, because we don't know this U, because we want this U and we don't know the speed at the top here. Okay, so speed at the top here can be get from the combination of principle of conservation of energy. So now we go to the principle of conservation of energy first. From the principle of conservation of energy, so the total of energy is always constant. In this case, the total of energy is kinetic energy and potential energy. So at initial equals to at final. Okay, so let's say at final, the velocity is V. Okay, so now you substitute into here, into the formula of kinetic energy, half mu squared and half mv squared. And then potential energy at the starting point here is 0. So at the top here, potential energy will be mgh, where the height is equals to the diameter of the circle here, circular motion. So means 2L. Okay, 2L. So this comes from the formula mgh, formula of the potential energy. Okay, so now you can cancel the m. Okay, and then cross multiply the 2. So you get u squared equals to v squared plus 4gl. Okay, then you get L equals to u squared minus v squared per 4g. So we are going to find this v. We don't know this v. Okay, L is given, u is given, g also no. We know this. Okay, so now we are going to find v. So for the L here, this is radius of the circle. Why we make this as L? Because we are going to use the radius of the circular motion here. Okay, we are going to substitute into the next part from the centripetal force. Remember, two equations we form. So this is equation 1. So use centripetal force, F equals to mv squared per L. So you substitute this L into here. And then the force, centripetal force here is provided by two forces, mg and the tension in the string. Okay, we have tension in the string act downward, and mg also act downward. So that means they are in the direction of centripetal force. Acceleration, centripetal acceleration, and also directed at same as centripetal force. So therefore, it's a positive. So we add t plus mg. Okay, t plus mg. Okay, now substitute everything L into here. L into here. Okay, and then remember that the questions want minimum velocity, so the tension is 0. Okay, so this is the minimum velocity. Tension, remember, cannot be 0, so we must get the minimum velocity. The minimum, remember the minimum velocity, so T must be 0 here. And cross multiply. Cancel the M. Okay, cross multiply to get V. Okay, don't forget L. Okay, L, because the question asks in terms of U. The question, read the question. We read the question again. Determine the minimum velocity of Q in terms of U. Okay, so you substitute L into here and cancel the G. Now you can see that our expression here. Okay, equation here only has two terms, V and U. So you cross multiply, you get U squared minus V squared equals to 4V squared. We rearrange the equation to get V. So you get V equals to U per cert 5. So this is the answer. So the answer V, minimum velocity in terms of U. Okay, so now predict what happened to the body launch from B if its velocity is less than U. So if the velocity here, okay, is less than U, so what happened? What happened? The body will not rotate, less than U, not rotate, but it will swing with simple harmonic motion. Imagine this girl, this girl swing. If this girl swing with U velocity larger than enough velocity U to reach the top, so it will make one complete rotation. Okay, so this is the minimum velocity, so must be larger than this, so to complete, where at the condition where T must at least the minimum 0 for this minimum velocity. Okay. So what happened? The body will swing with simple harmonic motion or oscillating lah, oscillating. Okay. So I think we managed to solve question until question 16 only. Question 17, you can I can give the answer later. Okay, so that's all. I give back. I pass the session now to Cikgu Madam Don. Okay, Madam Don.
Okay, Alhamdulillah. We have reached the end of today's session. Congratulations to those who can follow our session from the beginning till the end. Before we end our session for today, I will announce the fourth or the last digit code for the credit claim. The digit is number 4. Okay, the digit is number 4. So all of you, please stop posting your comment for a while. And if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, okay? And activate the icon bell so that you will not miss the next class session. Then if you find that the lesson was beneficial, click like and share to your friends on your social media and share the goodness. Once complete, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Okay, link for the certificate and link to the claim credit are already given in the chat box. Okay, with the access code of hashtag class IUEDD. Please take note, the link will end half an hour after this live. Make sure to use the email EDD only to log in. Incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box. If you wish to get more information on the online classes, go to the academyyoutuber.com, and to those who haven't joined EDD yet, so you can join the EDD Junior Telegram. Okay, so once again, I would like to thank all students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from the teachers throughout Malaysia for all the students throughout the country. Thank you too for being a YouTuber Academy supporter. I think that's all for now. See you in another session. Do not forget the hashtag bermula percuma, selamanya percuma. Stay safe till we meet again next week at the same day and same time. Thank you. Assalamualaikum and bye. Okay.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.